All right, let's get right into it. For a while now, we've been on this mission to get AI agents to actually do stuff for us in the real world. But it turns out we might have been teaching them completely the wrong language. Today, we are going to look at a huge shift in how we get AI to go from just talking to actually taking action. You know, we're moving so far beyond just simple chatbots. The real goal here is to have AI agents do things for us directly. I'm talking about managing files in your Google Drive, searching through a code repository, or updating a customer's record in a database. They're becoming actual digital assistants. But there's a catch. There's a really big problem. The way most of these agents have been built, well, it has a fundamental flaw. It's clunky, it's super expensive, and it really limits what they can actually achieve. It's like we've handed them a pair of scissors and asked them to build a house. So how did we even get here? Well, the first big breakthrough was this idea of giving the agents tools. This was the moment they could finally reach out and interact with the world outside of their own brain. And the key to this whole thing was something called the Model Context Protocol, or MCP. The best way to think of it is like a universal translator. It created a common language so that any AI agent could connect to any external tool. And just like that, a whole new world of capabilities opened up. So here's how a typical tool call actually works. It's this constant back and forth dance, right? The model says, I need to do this, so the system has to pause everything to go run that tool. Then, the entire result, no matter how big, has to get stuffed back into the model's brain as new input. And this happens for every single action. And as you're about to see, that is a huge, huge problem. And that whole multi-step dance leads us right to the main issue, which you can think of as a crushing token tax. Every single one of those steps in the dance costs us. It costs us time, it costs us computing power, and it costs us money in the form of tokens. Now, this might be fine for one simple little task, but what happens when you try to scale it up? What happens when an agent needs to use dozens or maybe even hundreds of tools, one after another, to get a complex job done? Well, that's where this entire approach just completely breaks down. And this quote just brilliantly sums up the entire problem. It really nails it. Tool calling is a foreign language to these models. Sure, they can learn some basic phrases, but they're never going to be fluent. They're never going to be elegant. It's just not their native tongue. So here's why. It all comes down to this massive difference in training data. The models, they've only seen a tiny little set of fake, made-up examples of these tool calls. But what have they seen billions, and I mean billions of lines of? Real-world code. They are native speakers of Python and JavaScript and TypeScript because that's the world they grew up in. That's what they were trained on. And this creates two enormous bottlenecks. First, you've got context overload. Imagine having to read the instruction manual for every single tool you own every time you want to use one, and you have to cram all of that into your short-term memory. That's what the model is doing. And second, it is incredibly wasteful. Data gets pulled into the model only for the model to immediately pass it right back out to the next tool. It's a massive tax on every single thing it tries to do. Which, finally, brings us to the really elegant solution. Instead of trying to teach the model this clumsy new language, what if we just let it speak the language it already knows fluently? What if we just let the model code? I mean, just look at this perfect example. The old way, over on the left, it's just painful. The model has to read an entire document into its memory just to spit that exact same document back out to another tool. But look at the right. With code, the model just writes two simple lines. It connects the services directly. The actual data never even has to pass through the model's brain. It's an absolutely brilliant shortcut. And the result of that one simple change? For that task, it's a 98.7% reduction in time and cost. Let me say that again, 98.7%. That's not a small improvement. That is a total game changer. And this chart just drives that point home. I mean, look at the difference in token usage. The old tool calling method burned through 150,000 tokens. The new code execution method, just 2,000. The difference is it's astounding. Okay, so it's way faster, it's way cheaper, I get it. But this immediately brings up a huge question, right? If we're letting an AI just write and run code, how on earth do we stop it from going completely off the rails? Well, the answer is all about building a secure foundation. This really is the critical question.
You can't just let an AI run whatever code it wants on your system. So, how do you give it the incredible power of code without creating a massive security hole?
The answer is modern sandboxing technology. For all the simple, quick tasks, you can use something called V8 isolates. It's the same tech that powers your web browser. They're incredibly lightweight and can be spun up and destroyed in milliseconds. Then, for the bigger, more complex jobs that might need a full Linux environment, you can just use containers. The point is, we have the right tool for any level of complexity.
And this whole approach is just fundamentally more secure. The sandbox is totally locked down by default. And here's the best part. Instead of handing the AI the secret API keys to all your tools, which it could easily leak, you just give it secure plugs that connect directly to the tools it's allowed to use. The AI code never even sees the password. It just knows the connection works. So when you put it all together, the raw efficiency of letting the model code and the incredible safety of modern sandboxing, you get a whole new generation of agents that are just smarter, faster, and way safer. And this unlocks some amazing new abilities. Agents can now browse for tools like you'd browse through files on your computer, only loading the ones they actually need. They can chew through huge amounts of data and only show the final summary to the model. They can use powerful programming logic like loops and if-then statements, and, this is a big one, they can work with sensitive data without that data ever passing through the AI model itself. That is a massive win for privacy. So this all leaves us with one final big thought. By making this shift from clunky tools to clean code, yeah, we've made our agents way more powerful, but it also kind of changes our relationship with them. So the question to really think about is this. Are we just teaching our AI to be a better assistant? Or are we actually teaching it to be a better developer?